Yeah.
Okay, hi class. Right, so today we continue from our previous lesson. Okay, so before this, you already learned about the heart, right? So the structure of the heart. Okay, and then what is the function for each part, okay, of the heart. Okay, so now we continue, right, to the structure and the function of the blood vessel. Okay, so before this, we already know that uh, what is the function of each part, right? Then after that, okay, we have to know how does the blood, okay, is being transported, okay, to all of the part of our body. Okay, so actually they got a three vessel here, three blood vessel, three types. Okay, so the first one is a vein. Okay, the first one is the vein. Okay, and the blood capillary, okay, and artery. So this is the three types of blood vessel. So each blood vessel they carry the different function. Okay, so we see the first one is the vein. Okay, so wait for a moment. Okay, so this is the vein. Okay, so the vein is actually carry deoxygenated blood. Okay, deoxygenated blood. Okay, and this is the lumen. Okay, the opening of the vein we call it as the lumen. Okay, and they got the valve here. Okay, I think you already know our heart has three types of valve. There is a bicuspid valve, tricuspid, and also semilunar. Okay, and then it has a thin wall. Okay, so they have a reason why they only have a thin wall here. Okay, and they carry the deoxygenated blood to the heart, and after that the heart will pump the deoxygenated blood to the lung, and the gas exchange occur. Then it will carry the oxygenated blood now that it goes to the artery. Okay, so this one is it goes to the heart first, and then the heart will pump out. Okay, then goes to the artery, then it will travel. Okay, it will travel to the all part of our body. Okay. Alright, so this is the vein. Okay, vein I already explained. Okay, what is a vein actually? What's the structure of vein? Okay, and then this is a blood capillary. So what is the blood capillary do? It connect the vein and also the artery. So it's like a connector here. Okay, and then this is the artery. So artery they bring the oxygenated blood. Okay, they bring the oxygenated blood, and the opening here we call it as a lumen, and also they got the thick, right? The thick muscular and elastic wall. So there's a reason why they need to have the thick muscular and also elastic wall. So I will explain it later. So for now we just see the structure first. Okay. Then this is the structure for the artery. Okay, if you have a close look, okay, so this is the structure of the artery. You can see they have a many layers. Okay, so that's why they are thick. Okay, and this one is a vein. Okay, you can see only like got like three layers. Okay, that's why they only got like thin wall. Okay, and but this one the blood capillary is thinner than vein. Okay, because they only have one layer here. Okay, so this is the our blood vessel. So this is the uh, artery, capillary, and vein. If you see under the microscope, you can see this is the artery here. So you can see it has a it has a thick wall, okay, and also muscular and also elastic. Okay, this is the lumen. The opening here we call it as a lumen. So all the opening here we call it as a lumen. Okay, so why does it the artery need to have the thick muscular and also elastic? Alright, and then but first we already know, first we already know that it transport the oxygenated blood. So this oxygenated blood, okay, will be sent, okay, to all the part of our body. So means it will travel far, right? So means they need to have the high pressure, okay, in order to transport the blood, okay, further. They need to have a high blood pressure. So that's why the wall here must be thick, okay, and also must be muscular and elastic. So it's easy for the artery to contract, okay, to contract and also to relax, alright. And then we compare it to the vein, okay. So vein here they only like have a thin wall here, okay, because they don't need the high pressure because this blood is deoxygenated blood. So deoxygenated blood is only to transport from the heart to the lung. It means it doesn't need the travel distance is not that far. So it means it doesn't need the high blood pressure. Okay, so that's why it doesn't have the thick wall here, only thin wall. Okay, because the blood is only need to be travel from the heart to the lung. Okay, for the gas exchange. Okay, so this is the capillary. Capillary, you can see the wall here is very thin. Okay, like only one cell. Okay, this is because, right? So this is the explanation that I did draw before. Okay, so let's say for the gas exchange, right? Okay, so you already know that the alveoli, right? This is the alveoli. Okay, and this is the blood capillary. Okay, so inside the blood capillary, there has a red blood cell there. Okay, so the red blood cell is deoxygenated blood. Usually when they come from the part of the body, this is the deoxygenated blood. Okay, and then the oxygen, you already know it will diffuse. Okay, it will diffuse to the red blood cell, and the carbon dioxide will diffuse to the alveoli. Okay, so that's why they need to have the thin wall here. So it's easy for the gas, for the carbon dioxide and also the oxygen, alright, to diffuse. Okay, it diffuse to the blood capillary, and after that we diffuse to the red blood cell. Okay, so that's why they only need like one cell. The thickness is only one cell. Okay, it's only one cell, right? So this is for actually for the oxygen. Okay, because you already know the red blood cell is not carry the oxygen only, they also carry the nutrient, right? The nutrient and also the waste product. Okay, and then for the nutrient is actually come from our small intestine. Okay, so inside our small intestine they got the virus there. Okay, and the virus is also like only the thickness is only like one cell only. Okay, so inside the virus they got a lot of blood capillary, and also they got a lacteal there. Okay, I think you already learned that one in form 2. Okay, so this when we eat, right? So example, when you eat a carbohydrate, okay, we eat a rice. Okay, so a carbohydrate, then it will be broke down, right? Okay, it's a complex molecule. The carbohydrate is a complex molecule. So the digestion system, okay, we convert the complex molecule to the simpler form. Okay, so it can be absorbed okay, by our body. So let's say for the carbohydrate, it will be broke down to the glucose. Okay, and then the glucose will be absorbed by the vilus here, and then inside of the vilus you got the blood capillary. So inside the blood capillary there is a red blood cell. So that's why they only need the only like one cell. Okay, the thickness is only one cell. So because that one is easy for the nutrient, okay, to be absorbed by the blood capillary, and also to be absorbed by the red blood cell inside the blood capillary, and also after that it will be transported, okay, throughout our body. Okay. Okay, so that is the why they need to have a one cell thickness only, and also for a tree, why they have to need why they need to have the thickness. Okay, wall. Okay, the thickness must be thicker. Okay, for the artery wall. Alright, so let's see for the blood vessel. So this one is a comparison. Okay, so this is the diagram for the artery. You can see the lumen is only medium, but the vein is very wide. The lumen is actually the opening here. Okay, and this is the blood capillary. Okay, for the wall, alright, for the wall, they must have a thick, muscular, and elastic. Okay, I will explain why. And the vein must have a thin, less muscular, and less elastic. So I already told you why also, because they only travel from the heart to the lung. Okay, and the lung go back to the heart, and the heart will pump to all of the part of body. Okay, and then why they only have the one cell thick only. Okay. Alright, so how about the direction of the blood flows? Okay, for artery is away from heart. Okay, this one because they carry the oxygenated blood. Of course, the heart, okay, we pump out the oxygenated blood, okay, away from heart, right? Because it has to travel to all the part of our body. Okay, and then the vein is to the heart, okay, and the blood capillary is from artery to vein. This one is like connected, right? It's a connector, so that's why it's only from artery to vein. Okay, then how about the blood pressure? Okay, this one I already told you there has a high blood pressure, and vein is a medium, and blood capillary is low. Okay, and the type of blood being carried for artery oxygenated blood except the pulmonary artery, and the vein deoxygenated blood except the pulmonary vein. Okay, and then the blood capillary is oxygenated blood from the artery and the deoxygenated blood to the vein. Okay, so this is the type of blood being carried. Okay, the heartbeat. Okay, so when our heart is beating, okay, the sound lap dub is produced. So the lap dub sound can be usually be heard using a stethoscope. Okay, let's say when you go to see a doctor, okay, so the doctor will check your heart rate by using the stethoscope. So they will put the stethoscope on your heart, okay, and then what sound that the doctor will heard. Okay, so you heard the lap dub sound. Okay, so before I continue, right, let's see how actually the lap dub sound, okay, look like. Okay, so this, you see, there's a lap dub sound. Okay, and you can see there's the opening and the closing of the valve there. Okay, right, see, so this is the valve. Okay, so actually the lap dub sound is produced by the closing of the valve. Okay, so we see that later. Oops, sorry. So all this is the valve. They got 4 valve, right? Bicuspid, tricuspid, and 2 semilunar valve. Okay, so I stop here first. Oops, right. Okay. Okay, lap dub sound is produced by closing of valve, okay, in the heart. Okay, by closing of valve in the heart. Okay, and the dub sound is produced by closing the semilunar valve. Okay, by closing the semilunar valve in the aorta and also the pulmonary arteries. Okay, so this one we call it as a diastole. Okay, so dub sound is produced when the semilunar valve is closed. Right, semilunar valve is closed in aorta and also in the pulmonary arteries. Okay. Okay, so this is the diagram. Okay, so you can see this is semilunar valve, right? So semilunar valve is closed now. Okay, so that one, the sound will be dub sound. Okay, so dub sound. Okay, so means when this one closed, the semilunar valve closed, the tricuspid and the bicuspid valve will open. Okay, so the blood will enter the, okay, the semilunar valve is closed, the bicuspid and tricuspid valve will open. Okay, semilunar valve closed, okay, tricuspid and bicuspid valve will open. Alright, and then the blood will enter the atrium. Okay, so since this one, the tricuspid valve is open, it will enter the atrium and it goes to ventricle. Okay, so at this time, the ventricle is at a relax. Okay, it's relaxed. Okay, the muscle is relaxed. Alright, so that will produce the dub sound. Okay, when the semilunar valve is closed, the tricuspid and bicuspid will open. Okay, and the blood will go back, we go to the atriums and goes to the ventricle. Okay, so at this time, the muscle of the ventricle is relaxed. Okay, it's not contract. Okay, so produce the dub sound. Right, so next, okay, and then we call it, that one is a diastole. Okay, next is the, so this one I already explained, the reading of blood pressure that flows and fills the heart is called as a diastolic pressure reading. Okay, so when the blood goes to the atrium, goes to the ventricle, we call it as a diastolic pressure reading. Okay, if you read the blood pressure, that one is the diastolic pressure. Okay, the one that the blood enter the atriums and in the ventricle and the semilunar valve is closed. Okay, for the both sides. Okay, and then the next one is a lap sound. It's produced by the closing of tricuspid and bicuspid valve. Okay, between the atrium and also the ventricle. Right. So now the semilunar valve will open. Okay, now the semilunar valve will open. Okay, the tricuspid and the bicuspid will close. Okay, so just now the blood is already entered the ventricle, right? So this one will close. Okay, and the ventricle will contract. Okay, and the blood will, so when we contract, the pressure here will be high, right? So it will push the blood. It goes to the pulmonary arteries here. Okay, right? And also for this side also is the same actually. The process is same for the both side. Okay, but this one I just use the right one, okay, to explain. But at the left side also they occur the same thing. Okay, so this one, the ventricles contracts. Okay, you push the blood goes to the pulmonary arteries. Okay, right? And this one, okay, it will open. Okay, the semilunar valve will open. Okay, it will produce the lub sound. Okay, the lub sound. Okay, then it goes to the, this one is a deoxygenated blood, right? So it goes to the lung. Okay, and then the oxygenated blood become the oxygenated blood, then go back to the pulmonary veins. Okay, and then go back to the aorta. Okay, so that's the process, right? Okay, so I repeat again. For the dub sound, semilunar valve close. Okay, by tricuspid and bicuspid open. Okay, so the blood will enter the atriums. Okay, since this open and the valve here is open, the tricuspid valve is open, it will go to the ventricles. Okay, so it produces the dub sound. Okay, and this is called as a diastole. Okay, now after that, the ventricle will contract. Okay, and this one, the valve will open. This one will close. Okay, so when this one is open, the blood, this one, the muscle here will contract, right? So we contract, it will push the blood. It goes to the artery pulmonaris. Okay, and this one will produce the lub sound. Okay, this one we call it as a systole. Okay, before this a diastole. Okay, diastole is dub. Okay, lub is a systole. Okay, right? So that's how does the systolic and diastolic cycle occurs in our heart. Okay, so I hope you can understand. Okay, so I make like a summarize, right, what happened during the dub and the lub sound. So dub, semilunar valve close. Okay, and then blood flows from the atrium to the ventricles. Okay, all right, and then this one is called as a diastole. Okay, and the lub is the tricuspid and bicuspid close. Okay, and then the blood will enter the artery, the pulmonary arteries of the aorta. Okay, all right, so that one we call it as a lub. Okay, and call it as a systole cycle. Okay, all right. Before I move on to the next one, okay, for the cardiac cycle, so let's see one video. Okay, how does the cardiac cycle? Okay,
When the ventricles relax, the ventricular contraction causes the atrioventricular valves to close.
Okay, so this one is a semilunar valve.
Ventricular contraction causes the atrioventricular valves to close, which signals the beginning of ventricular systole. The semilunar valves were closed.
Okay, so the semilunar valve will close. Okay, so the semilunar valve will close. Okay, you can see the blood is entering the ventricle
During the
now.
previous diastole and remain closed during this period.
Okay,
Continued ventricular contraction increases pressure in the
okay, so now you can see the tricuspid and bicuspid valve is closed and the semilunar valve is open. Okay, just now when this one closed, they produce a dub sound. This one is a diastole, right? So now the ventricle is contract, so it push the blood goes to the pulmonary arteries, right? Okay, so now you can see the semilunar valve, okay, is open.
ventricles above the pressure in the aorta and pulmonary.
So you can see both of it open. Okay, so that's allow the blood, okay, goes to the aorta or to the artery pulmonaris. So that one will produce the lub sound. Okay, we produce the lap sound. Okay, so remember dub sound, semilunar valve is close. Okay, lap sound, the tricuspid or the bicuspid valve will close. Okay, and diastole is for the dub sound, systole is for the lap sound. Right, so we have to remember that one. Okay, so we move on to the next one. It's a series of events. What's the cardiac cycle? So I already told you. I already show you the video, the cardiac cycle, the contraction, and also the relaxation. Okay, so the contraction is a systole and the relaxation is a diastole. Okay, the contraction is when the ventricle is contract and you push the blood. Okay, goes to the artery pulmonaris or goes to the aorta. So it's a contraction there. So that one is called a systole. Okay, so when it relax, okay, that one is when the blood enter the atrium and enter the ventricle, but the semilunar valve is closed. Okay, right. The average is a 72 heartbeat per minute. That one is the average. Okay, and then the one cycle, okay, one cycle for complete one cycle for the cardiac cycle is take only like 0.8 seconds. Very fast. Okay, this one I already explained. Okay, this one is on your textbook. Okay, next one is the regulatory mechanism of blood pressure. Okay, what is actually the blood pressure? The force of the blood exerted on the wall of the arterial blood vessel. Okay, so the arterial blood pressure, so it will be highest during the systole. So what is the systole? Systole means at that time the ventricle is contract and you push the blood, okay, going out from the heart, okay, whether through the pulmonary arteries or through the aorta. Okay, so at that time the blood pressure is highest. Okay, and it's lowest during the diastole because at that time the ventricle is relaxed. The muscle of the ventricle is relaxed. So that one it has the lowest during the diastole. Okay, so blood pressure reading X, Y, and MHT. Okay, I'm sure some of you, alright, or maybe your mom or your grandmother or your father, okay, they go to the checkup for the medical checkup, right? And the doctor will check the blood pressure. And they will give you reading like this, okay, 100 meters, 75, okay. So usually at the upper part, okay, it's very high compared to the lower one, okay. So at the upper part is a systolic, okay. Systolic, remember, the ventricle contract, right? The blood goes into the artery pulmonaris or go into the aorta. Okay, so that's why the pressure is very high, and we already know, okay, the blood from the aorta they need to travel right through all the part of our body, so they need to have the high pressure. So that's why this one is higher. Okay, and for the below part is diastolic. Diastolic is when the ventricle is relaxed. Okay, and just the blood uh, will enter the atrium and ventricle. So that is a diastolic. So that's why it's low. Okay, the pressure is low here. Okay, so I think you can understand why the upper part reading is higher than below one. Okay. Okay, the blood pressure reading usually take using a sphygmomanometer. Okay, based on the hearing the lap dub sound. Okay, because the lap is a systole, dub is the diastole, right? So they can measure the blood pressure by using our lap dub sound. Okay, and the normal blood pressure is 120/80, but it's different. Okay, for let's say for the young one and the old people. Okay, for the young people and the old people, they got different normal blood pressure. Okay, usually the older one they will be lower compared to the younger one. Okay, younger people. Okay, so and then they got the one receptor here that monitor the pressure of blood, that we call it as a baroreceptor. Okay, so this is the sphygmomanometer. Okay, this one I think we didn't use it anymore. Okay, we usually use this one. Okay, this one you can buy at the pharmacy, right? Okay, they sell it. Okay, so this one is to measure the blood pressure. Okay, pulse rate. So pulse rate is produced by shrinkage and the relaxation of the muscular wall of the arteries. Okay, so physical activity, gender, age, and health condition affect the rate of pulse. Okay, so alright. So I think I stop until now. Okay, I will assign you questions, okay, regarding of what I have teach you today. So I hope you can understand, right? So you have a question, you can ask me, you can text me. Okay, so take care, right? So thank you, class. Okay, bye.